Okay, it is time to start. Welcome to our lessons today in the afternoon of this is it now Thursday, or I don't remember, probably now it's Thursday. Oh, I have to share my screen there. Last time we started the concept of unit circle and also those trigonometric equations, and we started it by drawing this kind of picture of unit circle, and it was a circle which has its origin or center point in origin of the coordinate axis system, and the radius of that circle is 1 unit. So this is a circle which has radius of 1 unit. And then we had some example. I had a bad choice. I chose the value of the angle in my example to be 50 degrees, and it was a little bit bad choice, but still we found out that when we draw a line which is the left side of the angle, or left border of the angle of 50 degrees, so that the right hand side of that angle is in the lies between along the x-axis, and we could saw from this point in the arc of this circle, which I donated with the letter P. We could see that if we approximate the coordinate values of that point in the circle, and we approximated, or I approximated that it would be the x coordinate would be about 0.64, and y coordinate will be about 0.765. From only by watching or trying to approximate the values with the help of this graph or picture. And we saw that this first value, or this x coordinate, always tells the value of cosine of that angle, and the y coordinate tells us the value of sine of that same angle. Probably I did not remember to point or tell that when we know that those cosine and sine values from any angle, every time you can find from the coordinate values of these points in this circle, and we know that this is unit circle, so we know that every point from in the arc of this unit circle is located at the distance of 1 unit from the origin. So that means that it is impossible to get sine or cosine values which are more than 1 or less than -1, because that point would be somewhere outside of that circle. And that is the reason why we get these error messages from calculators if we are trying. How is this so? It's not. I don't know why is this camera not so clear. If I try to find out what is value of angle, if the sine of that angle would be, for example, 1.1, so I would take the inverse sine of 1.1, and this calculator gives us error message, error domain. That means that it is not possible to get a value of 1.1 for any angle, or for any sine of any angle. It always has to be between -1 and +1. But the tangent is different, as we saw when we draw this tangent line to the right hand side of this circle. We saw that the tangent point will be somewhere there when our angle is 50 degrees, and we approximated that this coordinate here is about 1.2, and that tells us the value of tangent for 50 degrees. So it is possible that tangent value can be whatever, from -infinity to +infinity, whatever. And we checked those approximate values from our calculator, or with the help of a calculator. I saw that this picture was quite easy to find approximate values for sine, cosine or tangent for any angles, simple by drawing this kind of circle. I think long time ago, before we had any calculators, or before we had any tables of trigonometric functions, probably this method was used by finding out the values of sine, cosine or tangent. This is two numbers accuracy is enough for many practical applications. I think mankind has managed to live probably thousands of years, or at least hundreds of years, without calculators or those tables of functions. And then we started to solving these kind of trigonometric equations, and we took this kind of example. We tried to find out what is the value of angle if the sine of the angle was this kind of number there. And we first took our calculator and find out that the angle, or one solution for that equation is about 13.7 degrees. But then we had this Excel sheet. I try to show you again. We had this Excel sheet where we saw that this sine this is sine curve, and we saw that the sine has a period of 360 degrees. So every 360 degrees the curve started to copy itself. So we just have to cut this part from this curve and just paste them to the row, and then we can get the whole sine curve. So when we knew that the period of sine was 360 degrees, so then we could approximate that the solution for this equation would be 13.7, or that angle which we get from calculator, and then plus or minus some multiplication coefficient from starting 0. When we take that value of 0 there, then we actually get the value what we get from calculator. But then the n value there can be 1 or 2 or whatever integer or whole number there. And we checked from one example that I think we took from some random number and tried to test if that value of angle also was a solution for this equation there. And then I tried to find out that there are other solutions also. we have more solutions there, and the reason for that was also again this unit circle. Sorry that this those doesn't belong to my lesson. And we saw that for example 50 degrees here, the sine value of that was about 0.76, but when we go round the circle to at least approximate to this point, we see that this angle also had the same value of sine, because the point in the circle lies in the same horizontal line there. This point also has y coordinate, the same as here. So we can see that because this picture there is some kind of mirror image, so if we had, unfortunately I don't have any mirror here, but if we had, can we use this as a mirror? Yes, probably my phone will show you that this will be mirror image there. So that angle there is also 50 degrees. There, I will use my pen here. This is also 50 degrees there. So the angle from starting to the positive, from the positive x-axis, would be 180 minus 50 degrees, and that was our other solution there. Of course, the angle was different than in this picture, but we get from the calculator the one value, and then the other solution would be angle which we get by subtracting 180 minus 13.7 degrees, and it will give us this solution there. So there are two solutions for this, or there are infinite number of solutions, but they all solutions can be written either in this form or in this form. There are no any other solutions. And now we will continue with these examples. I will take an example of cosine equation. If I just find a paper, I think I had paper somewhere here. Did we have any number? Just example. Let's continue by using just example here, and we will have equation cosine alpha equals 0.317. The first you might think that the solution would be exactly same as for a sine equation, but there is one difference. We will see it soon. Solution. First, calculator or Excel or other program that can use cosines or trigonometric functions. We will check what is cosine minus 1 or inverse cosine of this number there. I will use this calculator. Cosine minus 1, 0.1317. About 71 degrees. Let's use more decimals. Degrees. This is one solution. Then I could use this this unit circle here, but I'm not going to use this because usually you don't have these unit circles with you when you are solving these kind of equations. Let's draw that by hand. I will draw some kind of circle here. I try my best, and this is the best I could. And there is origin there. Well, I will use this so I can get a little bit better picture. And then now we remember that the value of cosine we find from the y-coordinate or the vertical coordinate, and now it is about 1.3, and this is 1 unit. So here y-coordinate is, sorry, I said incorrect, we are solving cosine, so we will use x-coordinate. So this is horizontal coordinate, so x-coordinate. So this is the place where the x-coordinate equals 1 unit. So the 0.3 is about here. I should have drawn a better or bigger circle, but I will use my arrow here, and I will show that here x is approximately this. And where is the angle who has that kind of property that it will give the x-coordinate of the point in the circle the same as this 0.3, and we can see that here is another one. Let's use this color. No, that is not a good choice. I will use. There is another one, and we can see that this is actually the angle we got from calculator, 71 degrees about. So here we find the 71 degrees. I have a very bad drawing, but if I use my angle calculator or angle measuring machine, so I will, well, not bad. It will, my picture shows that this might be about 68, about 68 degrees. If I had to draw, if I draw a better circle, I would get a more exact value there. But this is not important. The important is just to find the solution for that trigonometric equation. And as I told that, so we saw here, there is another solution there if I continue drawing this dot line here. So the other one will be here. We have two options. The easy one is to choose the same angle value as here, but use minus sign, because when we are rounding the circle in the counterclockwise direction, this is plus or positive direction, and if we are going this direction, this is negative or minus direction. So in this case, this first angle there is plus 71.5 degrees and the other one is minus 71.5 degrees. So all solutions for this equation, so all solutions for equation is alpha equals plus or minus 71.5184 degrees plus, how did I wrote that last time? Yes, you can, no, sorry, I will use this. You can use this method where you will use the plus minus sign there, and then the integrals will be from 0, 1, 2, so there will be only positive integrals. But we could also use the method by using only plus sign here and n times 360 degrees. In cosine we have the same period as in sine. It is also the 360 degrees, because when we are moving from this angle, whole circle, we are adding 360 degrees and we will be at the same place there. Or if you are watching the point in that circle there, every 360 degrees we will be at the same place. And same happens here. If we are adding 360 degrees for this angle there, we will be at the same place again. So this will be also solution. But if we are using here positive n, then we have to tell that this n starts from somewhere, from minus infinity, minus 2, minus 1, 0, 1, 2, etc. So you could use both methods, either plus sign here, but then you will use all whole numbers, including negative numbers. But if you use this plus minus sign there, then you will use only positive n values there. So this will be the answer for that equation. I will take that picture of that Excel again to see that the period for cosine actually is also that 360 degrees, as you can see here. When angle is 0 degrees, then the cosine value will be 1, and next time the cosine value will be 1 is at the point where angle is 360 degrees. So that is a solution for cosine equation. This is, I would say, this is maybe the easiest one of these three possibilities. I would say that this sine equation is most hard one, because you have to always find the other angle with this method. But this cosine method, you will get the one value from the calculator, the other one is by adding minus sign there. So that was cosine equation, and let's take a last one, or it is not last one, but the last of these three simple equations, where we have unknown only in this form, alpha there, cosine. Inside of cosine there was only simple angle alpha, and also here in this sine equation we had only simple alpha there inside the sine. Let's take that cosine tangent example. Tangent alpha equals minus 0.638. Let's again take that unit circle. I will draw a new picture there, but in this paper. But let's see first this picture there. What does that mean that tangent gets value of minus 0.6? We saw that here we had this tangent line, and 1.2 or plus 1.2 will be the height of this point there. So when we have the value of minus 0.6, that will be about, because this is minus 1 here, so 0.6 would be about here. This is 1 unit, and 0.6 unit would be about here, I would approximate. And that means that the angle would be like this. So we will get this angle will give us tangent value of about minus 0.6 or about that there. But there is also another one here. This angle here also gives us the same tangent value there. We can see that this is 180 degrees, and this is the period of tangent, as we probably looked from this Excel sheet last time. Tangent here. We have this picture there, or graph of tangent. We see that this tangent is this kind of some kind of logistic curve. Sometimes it is not logistic curve, but it looks like a little bit that. There the tangent gets the value of 0, and the next place where it gets the value of 0. Yes, so sorry, I was in the no, what is the problem? No, this is not 180 degree. For in my eyes this looks like 180 degrees, but it's 150 degrees there. So this point there is 180 degrees there. So we see from 0, then 180 degrees, 360 degrees, etc. I think this is 540 degrees, but we can see that the period of the tangent curve is 180 degrees. So when we are solving this kind of equation, again we use calculator first. Inverse tangent of minus 0.638, and let's see what we find from our calculator. Inverse tangent minus 0.638 minus 32 degrees minus 32.5378, etc. degrees. after that we watched that unit circle already, but I will try. Circle is hard to write like this. I try to draw a better one now. And there is again origin in the middle of that center point of that circle. It's x-axis there and y-axis there, and we are solving now the tangent equation, so we draw the tangent line in the right end of this circle, or vertical line. And when we are having here the value of -1, so this minus 0.6 is about, I would say it would be about here. So at that height we will find the tangent point there. And the angle will be here. And as we see from the picture that or see from the calculator that the value of the angle is about -32 degrees, and if we measure the angle here, you can see that it is quite near, because there's this horizontal line. I will continue that. There, so we can check the angle. This is very not so usually happens, this kind of thing, because now I draw this circle there and approximate the place of this 0.638 there, and now I can see that the angle there is about 32 degrees, and it is very near that value, which is the exact value. So this angle here, this is minus 32.5378 degrees. And because of that period of 180 degrees, we can tell that when we are adding 180 degrees there, we will be there in the opposite side of circle there, and the tangent value will be the same. If we check that, I have this value of that angle in the calculator, and if I add 180 degrees there, so I will plus, so this will tell answer will be, I will be adding to the answer, or this value 180 degrees, I will get this kind of angle there. And if I am checking what is the tangent value of that angle there, I will take tangent from the answer. That will be not surprise for us, because now I'm getting the value of minus 0.638 as it should be. So all solutions for the equation is alpha equals minus 32.5378 degrees plus or minus n times 180 degrees, and here this n equals 0, 1, 2, etc. Yes, there is a chat box. Is a question when we will study matrices. You have that course in the spring, starting I think in January, in the beginning of January. Those first lessons will be vectors and matrices is the course. So this was the second example from today's lessons. I will continue still with this. I will take another or the third example, but now I'm taking a little bit complicated yes, there is a question in the chat box. I would like to see an example. If you can send there or copy there some example what you mean. I'm not quite sure. I will take example of cosine, and right now we are having this kind of equation. Inside the cosine there is not simple alpha, but there is a expression of minus 3 times alpha plus 2 degrees, and that equals 0. Well, I am having the same value there. I took the same value for cosine there because where is my earlier example? Here. So this is almost the same, but there is not a simple alpha there, but there is this kind of expression. But the problem is only in this point. We are solving this with the same method. First calculator, and we will get the angle which has the cosine value 0.317, and we get this value there. And now we are having this cosine here. So if we did not solve this example earlier, we have to draw the unit circle in this point, or it is useful to draw that circle there. and there is again the center point in which is the origin of coordinate axis. And we notice that the 0.317 will be somewhere here, and we will find the angles there. If we compare the solution of this earlier example, now we have done this, sorry, not this, it was this. We have done this the same method there, and we found all solution with this method. Alpha equals this, but that was because there was only simple alpha there inside the cosine. Right now we are having this kind of expression there, but we are solving this with the same method. We are taking the value of that in the beginning of the solution in the left hand side, and then write this path there in the right hand side. But now we don't have alpha there, but we have this kind of expression there. So all the solution will be minus 3 times alpha plus 2 degrees equals plus minus 71.5184 degrees plus n times 360 degrees. And here n, I use this method here, so I will put plus minus sign there, so I will need to use only these positive integers there. So after this we will have the solution of the problem when we solve this equation here. We will first move this 2 degrees to the right hand side, so we will get minus 3 times alpha equals minus 2 degrees plus minus 71.5184 degrees plus minus n times 360 degrees. And then we are having minus 3 there, so we will divide this equation by minus 3. So the solution will be that terrible expression there. This looks like so terrible, so I will draw it with a little bit different way, because this is so hard to understand. What does this kind of solution mean? I will divide this in both into two parts. This part here, so I will divide this here by this, and then the other part is this here, and that means that I will get the solution minus 2 degrees plus minus 71.5184 divided by minus 3. Actually, when we are having plus minus there and we are dividing, if we divide by positive number, this plus minus sign will stay. But if we are dividing by minus sign, then these plus and minus signs will change places. So if we are very fundamental mathematicians, we would change the order. We will write minus plus there, and then 360 degrees divided by minus 3. Sorry, we have divided by minus already, because we changed the places of those signs there. Well, this doesn't change the solution at all. We can, from the final result or final answer, I will change the order again, plus minus, because it is not, you can minus or plus the value of this angle, which will be in this case 120 degrees there. So I will get the result minus 2 plus minus 71.5184 minus 3, and I will put plus minus there and 120 degrees. And then there will be two possibilities. I will write this so that I will first calculate what will I get if I take the sum sign there, and what I will get when I take that minus sign there. So two possibilities. Of course, you could leave this as a final result, but I don't like this kind of solution. It is so hard to understand or get some kind of approximation of the value of that angle, because there are those plus minus signs and minuses there, and again plus minus sign there. So I will take the first one, I will take the plus sign there, and now I will calculate that. Minus 2 plus 21.84 divided by 3, oh, sorry, minus 3. Minus 23.1728 degrees plus minus sorry, I have forgotten the n value there. Of course, you can't leave that away, because this n can be whatever value, whatever integer there. So I added those n's in the end there. So this is one possibility, and the other possibility is when we are choosing the minus sign there. So there will be minus 2 minus 75.15184, and also plus minus 120 times n. And let's check that also. Something like that. 24.5061 plus minus n times 120 degrees. let's check if this actually is the answer of that equation there. I will just take those negative values, those first values there. I will choose the value for n to be 0. So this will be not in the, this will be 0. So we could only use these angles there. And we have this -3 times angle plus 2 degrees. So let's check what we get. -3 times, and I will choose this angle there, -23.1728. That is the -3 times alpha. Here we can see -3 times alpha, and then I have +2 there. So as we see, we got the value 71.55, etc. And if we get the cosine value of this, we will get 0.317. There is some decimals after that, but it's because I have rounded the angles there. But as we see that the right hand side of the equation should be 1.317. And let's take another example for this value. I will choose the n to be 10. So if n is equals 10, then 120 times n is 1200 degrees. And we have this angle there, so I will take 24.5061, and I choose the n to be 10. So I will add or subtract. Let's take minus sign there. We can choose also that minus sign there, and 120 times 10. This is just an example of the one solution, and we are getting this kind of alpha value. And again, in the equation we should use this kind of expression inside of cosine. So I will take -3 times answer +2. This answer means in this calculator the last one last answer I got. So this, in this case, this minus number there. So this will give me this kind of angle, and if I take cosine of this, I should get this value there. Cosine of the answer, and as you see, it is 0.317, and again there are some decimals there, but it's because I have rounded those numbers there. So I guess we have solved this equation now. Okay, and now I think I will give you some exercises to practice this. I have to number these papers because I forget soon when I have had these examples and what is the order of these papers. So let's get you something to practice. Problems. This is first. So solve all the values of alpha which are solutions for these solutions for equations. I have to solve them also myself because I only had this one example pre-calculated, but these two ones I have solved myself.